The figure shows the velocity v is equal to x of t of the particle moving on a coordinate line. So whenever we have these type of problems, make sure you pay attention to what the graph is. So the graph shows the what? Velocity, okay? So we're going to do parts A through D. So for part A, when is the particle moving to the right? Justify. You don't have your iPad? Where's it at? You forgot it? I'm sorry, man. Okay. So what does this graph show? The what? The velocity. What's the relationship between position and velocity? The velocity is the derivative, okay? So derivative also means slope. Okay, so this is where this is tricky. This graph shows the velocity function, okay? So we don't know right now what the original graph looked like. But what this means is if I took the derivative, this shows me the derivative at 0, the derivative at 1, the derivative at 2, and so on. Okay, so moving to the right, you guys have a box from Friday that says the particle is moving to the right when the velocity is positive. So for a second, we don't really care about slope per se because this graph shows the velocity. Does that make sense? So what does this notation say when the velocity is what? Positive. So positive. So what you're looking at is where is this graph positive? Where is this graph above the x-axis? That's what it's asking you. So do you guys agree the graph is above the x-axis right there? And the graph is above the x-axis right there. Okay? So you would say the particle is moving right on the interval. Where does it start? Remember, time can't be negative. So do you guys agree it'll start at like 0 right here? So 0 to, when does it start to be negative? At 1. So from 0 to 1. And now this is a weird example. I'm going to say that this is about 4.6. Okay, it won't be like that on a test, but let's just say it's like 4.6. So 4.6 to 7. Guys, let's be mature. Cool. Now it says justify. You guys are AP students. You guys must write complete sentences because the velocity is positive. So like if this was an FRQ, this would be a point and then this would be a point because your justification shows you know what you're talking about, and of course the answer shows you know what you're talking about. Okay, questions on that? Yes.
So 0 to 1. When it's moving to the right, I'm looking at 0 to 2 when you're against moving to the right.
What's the definition of moving to the right? What does your note say last week? Your notes say it's moving to the right whenever the velocity is positive.
I see. Okay.
All right. So what do you guys think I'm going to ask you guys for part B? When is it moving left? So if it's moving right when it's positive, then it's moving left when? When it's negative. Okay, so where is the particle below the x-axis? Between which two numbers? 1 and what did we say this was? 4.6. We're not going to include 7 this time. 1 and 4.6. So it's moving left. On 1 to 4.6 because the velocity is less than 0. Okay. Describe when the acceleration is positive, negative, or 0. Oh my goodness. Okay. Now this is how I know I'm a nerd. I'm like really excited to teach you guys this because this is like the first time we've seen this. So you guys just look excited for a second. Okay. What's the relationship between acceleration and velocity? If you know the velocity, how do you find the acceleration? The derivative. In our class, we know that derivative means slope. Okay, so what you're asking about is this is the velocity graph, right? So the derivative of this is the slope. So where is the slope of this graph? Positive, negative, or 0? That's what this is asking you. Okay, so just make a note for yourself that acceleration is the derivative of velocity. So that just means the slope. Okay, so this is just basic math 1 stuff, guys. Y equals mx plus b. Is there anywhere where this graph is going up? Yes. Where does it start to go up? At what number? 2. And when does it start to go back down? 6. So you would say it's positive on 2 to 6. Do you guys remember those problems in pre-calc where I'd ask you guys, where is it increasing, decreasing, or constant? This is why, because this comes up in calculus. Now, where is it? Is anywhere? Oh, sorry, back up. Is it positive anywhere else besides between 2 and 6? So it's going up right there. Anywhere else is it going up? No. So negative. Where is it going down? 0 to 2. Anywhere else? This is not on purpose, guys. These are my same problems from last year. Okay. Is it 0 anywhere? So is there anywhere where the graph looks like this? No. So 0. Where does it say no intervals? Okay. Okay. I want to squeeze in a part D, so I'm going to make all this smaller. Okay. Part D. When does the particle have the greatest speed. Okay. So this is what I hope you guys remember, this analogy I told you guys on Friday. Remember I asked you guys like how many guys drive? When you guys put your car in drive and floor the gas pedal, your speedometer goes up, right? When you guys put your car in reverse, and hopefully you guys don't do this, floor the gas pedal, does your speedometer go negative? No, it goes positive, but you just move backwards, correct? So this graph shows the velocity. Remember, the absolute value of velocity is the speed. Okay, you guys follow me? So where does this graph have the highest speed? Highest velocity or lowest velocity? Yes. Do you guys agree that the highest point of this graph is 0, 2? And conveniently also the lowest point of this graph is 2, -2. But if I do the absolute value of this, what's the absolute value of -2? 2. So do you guys agree the maximum speed is 2? Because the absolute value of 2 is 2, the absolute value of -2 is 2. So the maximum speed occurs at t is equal to 0 and t is equal to 2. If it doesn't say justify, you don't have to justify. But just understand from here on out, this is just a deal we're going to make with each other. Whenever it says justify, you must say because and explain. Okay, how was that? We're good? And unit 5, just to let you guys know, I'm going to give you guys a graph, and you guys are going to graph the derivative based off this. This will be fun. Okay. All right. Last problem. Particle in motion. A particle is moving along a straight line. For t is greater than or equal to 0, the position x of t is equal to, my bad. S. This time it's S. T cubed minus 6t squared plus 9t, where t is in seconds and S is in meters. All right, so for part A, find the velocity at any time t. How do you find the velocity if you know the position? Derivative. So all this is saying is just take the derivative. So the velocity, v of t, is just equal to s prime of t. So power rule, if I take the derivative, I'm going to be given 3t squared minus 12t plus 9. Now, because this is the velocity, this is a rate of change. Okay, so what is the units here? Meters per second, good. And then if you're not sure, just think about it, guys. Seconds per meter, does that even make sense? No. Meters per second. All right. B. Find the velocity at t is equal to 2 and t is equal to 4. Okay. When you guys are working on your practice for this, which I won't give you guys till Wednesday. By the way, are you guys cool if I just combine 4-1, 4-2, and 4-3 into the same assignment? That doesn't mean it's going to be longer. It's just instead of giving you guys 3 different homeworks. Okay. Because a lot of it overlaps anyway. Okay. But whenever you guys are doing your assignment for this is a polynomial, right? This is the velocity, so all I have to do is plug in 2, plug in 4. Please try to do this without a calculator, because when you guys take your test, this would be a no calculator question. So v of 2, so that's at 2 seconds. Plug in 2, so 3 times 2 squared minus 12 times 2 plus 9. So it'd be 3 times 4 minus 24 plus 9. 3 times 4 is 12. (12 minus 24 is negative 12. Negative 12 plus 9 is negative 3 meters per second. Okay. Plug in 4. Three times 4 squared minus 12 times 4 plus 9. What's 4 squared? 16. 12 times 4? No. 48. 13 times 4 is 52. What's 3 times 16? Oh my goodness. What happens to the 48s? Hey, what is this? 9. Don't forget your units. Meters per second. So I'm pretty sure, but let's say the problem didn't ask you guys for units, but you included the units and it's wrong. I'm pretty sure on the AP exam, they just ignore it, as long as your answer is correct. But to be safe, I would just get in the habit of including the units every time. Okay? All right. Part C. Find all the times where the particle is at rest. So I want you guys to flip back to Friday. What does your note say to do to figure out when it's at rest? That's when what? Say it again. What does? Which part of the function? Huh? The velocity, thank you. The particle is at rest when the velocity equals 0. Because you're not moving anywhere. Our function is sleeping. So, do we have our velocity already? Set it equal to 0. So 3t squared minus, is it 12t? Plus 9 is equal to 0. So this is calculus, right? This class? Guys, this is a math 2 question. What should you always look for first when you're solving something like this? GCF. What's the GCF? Cool. Now, technically, this 3 doesn't matter anymore. So what you could do now technically is divide both sides by 3, because then those will cancel. What's 0 divided by anything? 0. So the 3 we don't care about anymore. So what I really care about is what this factors to. T minus 3. Now t minus 1. Now, in this case, it doesn't happen. So t is equal to 3. And t is equal to 1, right? What does t stand for? Time. And in this case, time is in seconds. What if you got a negative answer? No. Can time be negative? No. So if you get a negative answer in this case, you just ignore it, because a negative wouldn't matter in this case, because you can't, unless you guys have a time machine, let me know, because I want to make some money too. We cannot have negative time. So t equals 3 seconds, and t is equal to 1 second. The only time you do absolute value is when it asks about speed or something else. You guys will see right now. Okay, part D. When is the particle moving in a positive direction? Okay, pay attention to this one, because this one is important. If you go back to the directions, it says that the particle is moving along which axis? The x-axis, right? So if it's moving in a positive direction, which direction is positive on the x-axis, left to right? To the right. So where is the particle moving to the right? Didn't we do that in the last problem? When a particle is moving to the right, that means the velocity is greater than 0. So you're trying to figure out when is the velocity positive? That's what it's asking you. Okay? Do we have the velocity already? Yes, we do. I'm just going to slide this to a new page. So this is what you're going to do. We want, what's nice about this is we already factored it from the last problem. So we want 3 times t minus 3 times t minus 1. We want that to be positive. Now, in unit 1, when we did a lesson where I asked you guys to find the domain, and do you guys remember sometimes we would do a number line? And I showed you guys how to create what's called a sign chart. We're going to make a sign chart for this because we want to know when is this guy positive. So what you do then is on your number line, you're going to put the things that make this 0. So do you guys agree that it's going to be 1 and 3? Okay? Now, what's a special case about this is this arrow means the line goes forever, right? But what do you know about time? Time can't be what? Negative. So really, this timeline begins at 0 because you can't have negative time. So then what I have to do then is I have to pick numbers between each of these little numbers and plug them in and see what happens. Okay? So let's start with this one first. So unfortunately here I do have to pick a fraction, so I'm just going to pick a half. Remember, you don't really care what the number is, you just care about the sign. So if I pick like 1/2 and I plug it in, this 3 is irrelevant. We don't care. It's positive, it doesn't matter. If I plug in 1/2, what's 1/2 minus 3? Positive or negative? Negative. If I plug in 1/2, what's 1/2 minus 1? Negative. What's a negative times a negative? Positive. What's a really nice number to choose between 1 and 3? 2. If I plug in 2, what's 2 minus 3? Positive or negative? Negative. If I plug in 2, 2 minus 1, what's a negative times a positive? Negative. Okay? If I plug in 55, doesn't matter. Anything that's bigger than 3. So I like to be dramatic and pick something really big. So 55. 55 minus 3. Positive. 55 minus 1. Positive. A positive times a positive gives me a positive. So if we want to know when is this thing positive, I'm going to highlight where we have pluses on our number line. So we can say the particle is moving in a positive direction on the intervals 0 is less than t, which is less than 1. Is everybody cool with that? Because between 0 and 1, it's plus. And what would I say here that shows this number and everything else? This is an inequality symbol, right? Are the numbers getting bigger or smaller or going that way? Bigger. So I can say and t is greater than 3. If you guys wrote 3 to infinity, that's okay too. But I don't for time, I don't like to use infinity if I can avoid it.
To clarify, we need to write inequalities or just intervals? Because I'm thinking like brackets.
You can use either one.
Okay.
Like if you guys were to write 0, 1, union 3 to infinity, that's okay. The important thing is, do you guys know how to come up with this? Because that's the big thing. Okay, how many more parts do I have? I have way too many tabs open. There's 2 more parts after this one too. I know.
Should have just said it to
I know. Okay, this is tough. What did I say? Oh. I'm trying to think if you guys know enough right now to me to show you guys this. Oh yeah, we do. Yeah, we do. Okay. Total distance traveled. Okay. So, I know I'm recording this so you guys won't be able to see me on YouTube, obviously, thank God. Okay. But imagine I move from here and walk all the way around my classroom. And land in the same spot. Okay? I don't know how many steps that is. Let's say that's like 50 steps. Okay? That means my distance traveled would be 50 steps. Okay? But my displacement would be 0 because I started and landed in the same place. That's the difference. Displacement is basically if I went positive and then negative and then positive again and then back to here. So the displacement would be 0, but the distance traveled would be this distance plus that distance plus that distance plus that distance. Does that make sense? Okay. So whenever it asks you about total distance, we need an absolute value. So if we use our little number line, I'm just going to copy and paste it. We know that the particle is positive between 0 and 1. We know that the particle is negative between 1 and 3. And then anything after 3, it's also positive. So between 0 and 5, we have these intervals I have to pay attention to. 0 to 1, 1 to 3, and then 3 to 5. Because if I put these little time intervals side by side, this would together make up 0 to 5. What do we know about 0 to 1 from our number line? It's positive. Between 1 and 3, it's negative. And then anything after 3, positive. Okay? To find the total distance traveled, I want you guys to think about like f of A minus f of B. You're basically just taking the y values and subtracting them. So from t equals 0 to t equals 1, the total distance is going to be the absolute value of s of 1 minus s of 0. So to save us time, I already plugged these in for us. So I want to make sure you guys understand this. Is everybody cool with this idea? That comes from our number line, right? We already did that work. Total distance traveled, because I just showed you guys, you have to do the absolute value of where you landed minus where you started. So S of 1, S is position. So I'm taking my position function and plugging in 1, and I'm plugging in 0 and subtracting. So S of 1 is 4, minus S of 0 is 0. 4 minus 0 is 4. The absolute value of that is 4. Now do the middle. From t is equal to 1 to t is equal to 3, total distance traveled is going to be S of 3 minus S of 1, and taking the absolute value of that. So I did the work already. S of 3 is 0. S of 1 is 4. What's the absolute value of negative 4? 4. So then between 3 and 5, our last interval, S of 5 is 20. S of 3 is 0. 20 minus 0 is 20. So the absolute value of that's 20. So to get the total distance, I just have to take these three values and add them together.
the whole point like you like graph from the top by like saying if which was positive, which was positive, you scroll up. Positive, negative, positive. It gives me the absolute value.
You still have to do the absolute value to find the distance.
Yeah. When I need to include that writing in like the what do I say intervals. Yeah.
Yeah, because you have to break it up. We know it's positive, we know it's negative, we know it's positive. To be safe, you still should do the absolute value when it's total distance. This isn't the last time you'll see this, so just remember total distance, we need absolute value. Later on, you guys will use your calculator to do this with integrals. I'll show you guys how to do that, and it's same thing. You do the absolute value. Okay. What comes after, what's F? That's E. So what comes next? F? Is that how our alphabet goes? Find the acceleration. At t is equal to 4 seconds. So to find the acceleration, how do you find the acceleration? Second derivative. Don't we already have the first derivative? So I just have to do it again. So v prime of t is the acceleration. So the derivative would just be 6t minus 12. So then a of 4, if I plug in 4, it's just going to be 6 times 4 minus 12. 6 times 4 is 24. 24 minus 12 is 12. Now, what's the units here? Yes, meters per second squared. Or meters per second per second.
Does it matter if the first one has prime and the second one has double prime?
Like, yes. So if you put you can write S double prime. That's fine. But you can't put V double prime because then that'd be the third derivative, which is the jerk. Okay, last part. Okay, so we started talking about this on Friday. How do you know when the particle's speeding up? When what? They have the same sign, right? So acceleration and velocity are both positive or both negative. When is it slowing down? When the signs are opposite, okay? So this is the easiest way to do this. I'm going to highlight things and just try to follow along. We already have our little number line for velocity, right? Right, guys? So I'm going to copy, paste it. I'm going to label this so that way we know the difference. This is our velocity. We needed to do the same thing for acceleration. So this was our acceleration function. So when we do our number line, we have to know when this is equal to 0. Okay? So this one's actually pretty easy. If I set this equal to 0, guys, and solve, what would make t equal 0? 2. 2 times 6 is 12. 12 minus 12 is 0. So for acceleration, the only number that's on my number line is 2. Okay, you guys follow me? So if I plug in a number less than 2 but greater than 0, so 1. If I plug in 1, 6 times 1 is 6. minus 12. Do you guys agree that would be negative? If I plug in like 10, 6 times 10 is 60. 60 minus 12 is positive. Okay. Is everybody good? So okay. It's speeding up when they have the same sign. Aiden. So what I want you guys to notice is, do you guys see how this is red and this is red? Those are the same sign. So velocity is only negative between 1 and 3. Where does that overlap with the red of the bottom graph? 1 to 2. Good. Because this is only negative between 0 and 2. This is negative between 1 and 3. Those overlap between 1 and 2. Does that make sense? So it's speeding up on 1 to 2. And this is positive from 3 to forever. This is positive from 2 to forever. Where do those overlap? 3 to forever. Good. So, and 3 to infinity. Okay. Where do they differ? Pretty much everywhere else. So, do you guys agree the graph started at 0? Have we included 0 yet? So, what I'm saying is, if we start at 0, do you guys see how this answer started at 1? That means that because we haven't included it yet, do you guys ever notice that for increasing, decreasing is usually the opposite is your answer? Did you ever pay attention to that? So I haven't said 0 to 1 yet. Let's check. Between 0 and 1, this graph is what? Negative. Between 0 and 1, this graph is? Those are opposite. So it's slowing down. So it's going to be slowing down. Oh my goodness. 0 to 1. And I'm hearing different answers. You say 2 to 3. What are you saying? We already said 0. I like 2 to 3. Let's check. Between 2 and 3, this graph is negative, right? Between 2 and forever, this graph is positive. So between 2 and 3, for sure, this is positive. Between 2 and 3, this graph for sure is negative. So 2 to 3. As we get farther along, we're going to have an easier way to figure this out. Okay?